The origins of the Logan facility trace back to Anaconda Aluminum. After the Atlantic Richfield Company, ARCO, acquired the assets of Anaconda in 1979, the newly formed ARCO Metals sought to expand its participation in the aluminum marketplace. In order for ARCO Metals to participate in the RCS market, it would be necessary to build a modern aluminum rolling mill with the equipment and technology capable of producing both can stock and lid stock. ARCO committed approximately $465 million for construction. This would be the first major rolling mill constructed in the United States in nearly 2 decades. After an extensive site search, ARCO chose a 1,000-acre site in Logan County, Kentucky. The site, located in south-central Kentucky, 7 miles north of the town of Russellville, Kentucky, and 70 miles north of Nashville, Tennessee, consisted of rolling farmland in a predominantly agricultural area. The Logan County site satisfied several key requirements for the plant. 1. Adequate land for construction. 2. Suitable water resources. 3. Highway and rail access. 4. Available power from the Tennessee Valley Authority. And 5. Close proximity to customers. Also an important consideration was the work ethic of the area, since the plant was being designed to incorporate an innovative team management concept. Construction of the Logan plant, as it was known then, began in early 1981. The Logan plant was designed to be one of the most modern and automated aluminum rolling mills in the world, incorporating the latest automation, production equipment, and pollution control technology. For production efficiency and low operating costs, the plant was also designed to take advantage of economies of scale. Logan equipment was designed to produce and process the largest rolling ingots and aluminum coils in the world at high speed, while tightly controlling key product attributes such as thickness, formability, and surface finish, and also meeting demanding customer quality expectations. The Logan plant was initially designed for an annual capacity of 400 million pounds. To accomplish this task, the plant was laid out in an orderly production flow managed by autonomous business units. A centralized engineering and maintenance group took responsibility for plant-wide systems such as cranes, scrap monorail, power distribution, and water services. The 4 production business units were melt and cast, hot rolling, cold rolling, and finishing. Each unit contains specialized equipment and technology. Melt and cast. Melts alloys, refines, and casts aluminum rolling ingot from aluminum scrap and other alloying materials. Hot rolling. Converts rolling ingot into a coil. Cold rolling. Through successive cold mill reductions, converts hot mill coil to a finished coil at the customer-ordered thickness and strength levels. Finishing. Completes the process of customer coils by slitting to correct width and coil size, applying customer-specified lubes and coatings, and packaging the coils for shipment. The Logan plant completed construction and startup in late 1983 and began commercial production in 1984. Because entry into the can sheet market requires extensive product qualification and testing, products made during the early years of Logan included building products, distributor sheet, and household foil. These products were gradually phased out when Logan began supplying increasing quantities of RCS products and began its emergence as a premier supplier to the aluminum beverage container market. Construction of the ARCO Metals Logan plant was completed in 1983, with commercial production beginning in 1984. At that time, the Atlantic Richfield Company, ARCO, decided to divest itself of its metals businesses. Alcan Aluminum, wanting to expand its rolling capacity and its presence in the rigid container sheet RCS market, expressed an interest in buying the Logan plant. However, arguing on antitrust grounds, the Justice Department would only allow Alcan to purchase 40% of the Logan facility, with the balance retained by ARCO. This unique operating agreement resulted in two direct competitors in the marketplace sharing in the manufacturing capacity of the facility. The agreement also allowed each associate the opportunity to expand production capacities of the plant, either jointly or independently, depending on its own production needs. This set the stage for a series of capital investments, improvements, and expansions over the next 25 years that would expand and solidify Logan's position as a premier, efficient, and quality supplier to the beverage container markets. These expansions brought the total investments in Logan to approximately $1 billion and transformed Logan into the single largest rolling mill to make aluminum beverage can sheet in America. Its output has grown to more than 4 times its initial capacity, providing aluminum for 40% of North America's beverage can production. Logan's capital improvement projects during its history have achieved a variety of goals, including capacity expansions, increased energy efficiency, health and safety, improved process control and product quality, and environmental improvements. In addition to an annual capital budget of approximately $20 million, some of the major projects, expansions, and milestones over the years have included adding more efficient ingot preheating furnaces, promoting environmental stewardship by constructing a wetlands, expanding melting and casting capacity, upgrading and repowering the cold mills, adding automatic guided vehicles for more efficient material movement, adding high-speed cold rolling and slitting equipment in the Cold Mill 3 and Slitter 3 project, expanding the ability to make additional products with the Level Clean line, adding the capability to process recycled scrap in an environmentally friendly manner through the Recycle Center addition. With Logan Aluminum's ongoing capital and continuous improvement programs, the plant is well positioned to maintain its competitive position in the RCS marketplace for years to come. Logan Aluminum currently employs just over 1,100 full-time employees and also engages approximately 100 full-time contract employees. Logan will celebrate its 25th year of operation in the spring of 2009, which sees many of its employees also celebrating 25 years of service. One of Logan's greatest assets is its employees, and the list of employee accomplishments could evolve into a book. Approximately 25% of Logan employees have advanced degrees, and there are currently 70 team members taking college courses toward completing degrees. Logan Aluminum is a major contributor to United Way and recently held its best campaign ever, raising approximately $100,000 for local United Way agencies, which also accounts for 60% of the total Logan County pledges. Logan also supports junior achievement, both financially and by providing numerous volunteer consultants teaching business concepts to students in local schools. Through its recycling efforts and employee-donated time and money, Logan has helped build 13 homes in the community through Habitat for Humanity. Other events supported by Logan employees are the American Cancer Society's Relay for Life and the local Tobacco and Heritage Festival. An estimated 50% of employees volunteer their time in local governments, civic organizations, schools, and youth sports leagues. Employees have also generously responded to families following natural disasters. Each year, 2 blood drives are sponsored on-site by the American Red Cross, with employees donating over 200 units on average. Logan trains nearly 70 employee firefighters and emergency medical technicians each year to state requirements. And most of those also serve in their own hometown as emergency services volunteers. Logan is proud to have such dedicated employees who are committed to having a positive impact on the growth and success of the Logan County area. Logan Aluminum has special events for the staff that have become annual events that everyone at Logan looks forward to. Families gather at Easter for a huge hunt and then for the annual company picnic. There are fishing competitions and parties for employees that bring the staff together as an extended family. Logan Aluminum isn't just a highly successful company. It is a community within a community committed to bringing quality of life to its employees and to the population at large. The Logan aluminum process starts in remelt with various forms of internal and external aluminum scrap and other raw materials. These materials are converted into a final product called an ingot. Annually, Remelt produces in excess of 1.2 billion pounds of ingot. It takes approximately 750 trucks and 90 rail cars per month to deliver external scrap units to Remelt. Melt Prep Center is the first step of the process within the Remelt department. Metal prep operators make required calculations for blending of scrap into batch sizes ranging between 150,000 to 240,000 pounds. After calculations are complete, the operators will place the various types of aluminum scrap into large buckets. The batch is now ready to be transferred over to melt bay. From here, an overhead crane secures and lifts the bucket, transferring it to the melters. The melter roof is removed to allow the bucket to be lowered into the melter, where the scrap is unloaded and the melting process begins. It takes approximately 2.5 hours for the scrap to be melted from a solid to molten state. To assist the melt cycle times, molten metal is brought in from the recycle center and swarf furnace and added to the melter. Once the desired molten temperature of 1,375 degrees Fahrenheit is achieved, the metal processing step begins. Oxidized impurities, called dross, are skimmed off the top of the molten bath. The chemical composition is then tested and can be adjusted to meet customer specifications by adding hardener elements such as copper, manganese, and magnesium. Once the melting and processing of the molten bath is complete, it's ready for transfer to cast bay. The transfer takes place via two 6-inch diameter openings located near the back of the furnace floor. The entire batch of molten aluminum can be transferred in 12 minutes or less. The molten bath is drossed and tested again to verify customer specifications. Once the correct specifications are reached, the molten bath flows through a progressive series of filters to remove impurities, and it is distributed into the casting molds. The water-cooled molds turn the molten metal into a solidified state by removing heat. The entire casting process, which can take up to 2 hours, is controlled by computer systems that regulate furnace and filter temperatures, process gas flows, cast speed, metal, and water flow. Once the casting process is complete, the mold table is removed and the ingot is extracted by the crane. From here, the ingot is transferred to the laydown table or AGV stand and is sent to the hot mill for processing. Once an ingot is completed in remelt, it's sent to the hot mill for the next stage in the process. The ingot is placed on a transfer table from remelt and is moved to ingot storage or the scalper by an overhead crane. The external ingots are received via truck or rail car and receive the same treatment as internal ingots. After the ingots have reached ambient temperature, they're processed by the scalper. The scalper removes approximately 1/4 inch of aluminum from the top and bottom of the ingot. Scalping the ingot creates a smooth surface for rolling. The ingot is then transferred by overhead crane to the pusher furnace area. For the correct metallurgic properties to be achieved, the ingots are heated. The scalped ingot will be loaded into one of 3 pusher furnaces, which holds up to 32 ingots and are separated into 8 heating zones. Once the ingot has reached the proper temperature for the correct time, it's removed from the furnaces by the downender and placed upon the rolling table. Once the ingot has reached the reversing mill, the pulpit operator will begin forcing it through the mill, and the force of mill rolls will begin to reduce the thickness of the ingot. Additionally, force is applied to the sides of the ingot, which causes it to increase in length but stay the same width. Can body ingots will have to have approximately 17 passes to reach the desired thickness, and can end ingots will have approximately 27 passes. Once the ingot has reached a thickness of 6 inches, it will pass through the 6-inch shear, where a portion is removed. After 6 more passes, the slab will be 1 to 1 1/10 inch thick and is transferred down the rolling table, which is over 200 yards or 2 football fields long, to the 2-inch shear and the finishing mill. The 2-inch shear will remove another portion of the slab and it's fed into the finishing mill. The force exerted by the finishing mill's work and backup rolls causes the slab to decrease its thickness to 1/10 of an inch. Roll coolant is also applied to decrease friction and cool the rolls. Can body will take approximately 6 minutes to run through the finishing mill to form a coil, whereas can end will take approximately 8 minutes. Once the coil is complete, it's transferred to the exit conveyor car and inspected for any quality defects. The operator then welds the inside diameter of the coil and performs a final quality inspection before the coil is transferred to the cold mill. Once the coil is completed processing in the hot mill, it's transferred to the cold mill. Logan Aluminum's 3 cold mills produce approximately 1.8 billion finished pounds of rolled can sheet annually. If the metal was laid out, it would be roughly 734,000 miles and would go around the Earth 29.5 times. With having 3 cold mills, Logan is able to maximize their productivity by metal moving between each mill for processing. Coils are moved from the thermal staging or forced cooling area and placed on a system of conveyors. Next, coils are prepped where a few wraps are removed and a slight bend is placed in the end sheet. The coil is then run through one of 3 cold mills in order to achieve the desired thickness or gauge of the sheet. This is achieved by the work and backup rolls applying tremendous pressure to the sheet. The sheet is recoiled onto a metal sleeve. By running the coils through a variety of paths, the sheet can be taken from a thickness of 1/10 of an inch to the thickness of a piece of paper. Depending on the metal composition and required gauge, a coil could have gone from 1 to 5 passes on the mills. CM1 can take 3 to 5 passes from the breakdown stage to finish pass. CM2, originally designed as a foil mill, completes 1 to 2 finish passes on coils. CM3, a 3-stand tandem mill, can take a coil from breakdown to finish gauge in 1 pass. Once through the mill, coils are inspected for quality defects and finishes processing according to customer specifications. Scrap generated during the process is removed at the pup coiler. Here, the remaining metal left on the sleeve is unwound, making the sleeve available for reuse. The scrap is sent back to Remelt to be reused in their process. Once the coils have finished processing in the cold mills, they then move to the finishing department for completion. Additionally, a very integral part of the process is completed in the roll shop. Here, operators grind the rolls to remove any blemishes, replace bearings, and complete the buildup of the rolls for use again in the hot mill and cold mills. Annually, the roll shop grinds approximately 15,000 rolls. Once a coil has completed processing in the cold mill, it's sent to finishing for the last production step. The finishing department exists to put the final touches on Logan's 3 products: can body, can end, and tab stock. Machines trim sheet to final width, monitor sheet thickness with X-ray gauges, and apply customer-specific lubricants and coatings. Finishing team members are the last set of eyes to see the product before it reaches the customer. Therefore, quality inspections are critical. Can-end finishing process begins at the tension level line, also known as the TL. The TL uses a series of rolls to apply tension to flatten the sheet. Once the coil has completed at the TL, it is transferred to the coating line. Can end sheet is coated to protect the can contents from the metal. As part of the coating process, the sheet must be cleaned, pre-treated, and dried prior to applying customer-specified coatings. Annually, Logan spends approximately $22 million on coatings. After the coating process is complete, the coils are moved to the slitter to be trimmed or slit to customer-specified width and weight. Unlike can-end coils, the can body product does not require leveling or coating. Therefore, can body skips the tension level line as well as the coating line and moves directly to the slitters. The scrap generated from the slitting is placed in tubs, sent to Remelt to be used in their process. A new addition to the finishing unit is the level clean line, or LCL. The LCL levels, cleans, and applies lubricants to tab coils. The coils then require third-party processing to slit from 60-inch width to approximately 2 to 4-inch wide coils. Once the coils have been trimmed to customer specifications, they are transferred to the pack and ship line via transfer car or crane. The coil is then placed into the cocoon packaging system, where it receives a vapor-proof plastic coating and is readied for transport. The coil is inspected again for any handling damage and moved into the finished goods area to await transport to the customer. An operator will load the packed coil onto a semi-truck or rail car to be shipped. From the loading docks, the packed coils will be delivered to Novalis and Arco customers. Logan's success is reliant upon the support of the Engineering Site Maintenance (ESM) unit. The ESM teams have a broad set of responsibilities that intertwine with all units in the facility. These teams are comprised of material handling, engineering, maintenance shop, shutdown crews, utilities, facilities, and oversight of the on-site contractors and general technician trainees. Logan Aluminum's Environmental Safety and Security (ESS) unit is comprised of 11 individuals with various fields of expertise. The ESS unit provides support to the production centers to ensure safety, environmental, and ergonomic compliance, assists with machine safeguards and environmental projects, and conducts emergency response training. LAFD EMTs, Logan Aluminum Fire Department, and Emergency Medical Technician. Logan is proud of its recognition as an industry leader with regards to its world-class safety performance. The power, protecting our workforce by eliminating risk process, is a critical element that contributes to this success.